Till now, we saw the trigonometry dealing with just a single angle. What if there is a more than one angle and trigonometry gets compounded and deals with a big formula? So today, let's see what is compound angles and let's deal with the list of formulas, the trigonometry. Compound angles is nothing but it's a combination of more than one angle. So how the trigonometric ratios expand into a formula will be dealt in this. So let's see the basic identities. One, sin of a comma b, a plus b is equal to sin a cos b plus cos A sin C, sin B. So, similar way, sin of A minus B is equal to sin A cos B minus cos A sin B. Cos of A plus B is equal to cos A cos B minus sin A sin B. Here, for cos of A plus B, cos A cos B minus sin A sin B, and for cos of A minus B, cos A cos B plus sin A sin B. This is very important to be noted. So we understood these four different types of formulas. So we all know that tan is a derived quantity of sin by cos. So what is tan A plus tan of A plus B? Tan of A plus B is sin of A plus B by cos of A plus B. You all know. And let's simplify this. Sin of A plus B is sin A cos B plus cos A sin B divided by cos A cos B minus sin A sin B. Now, let's divide the numerator and denominator by cos A cos B for clearance. Sin A cos B plus cos A sin B whole divided by cos A cos B divided by cos A cos B minus sin A sin B whole divided by cos A cos B. We would get sin A by cos A, cos B gets cancelled. We would get tan A. Same way here we would get cos A cancel and tan B. So tan A plus tan B divided by 1 minus tan A tan B. Now same way we can take it up. Tan of A minus B is equal to tan A minus tan B divided by 1 plus tan A tan B. Okay. So these are 6 different formula, and we could extend this also. Like we all know, cot of A plus B would be 1 by tan of A plus B, which is cot B cot A minus 1 divided by cot B plus cot A. Same way, cot of A minus B gives cot B cot A plus 1 divided by cot B minus cot A. Let's remember cot B first and then cot A first so that there won't be any confusion between cot of A plus B and cot of A minus B in the denominator part. And there are, so since we have this as equation 1, 2, 3, 4, we can infer some other equations also from this part. So let's do that too. From 1 and 2, 1 plus 2, which means sin of A plus B plus sin of A minus B. This would result in getting 2 sin A cos B. Because sin A, like cos A sin B would get cancelled and this would be added twice. So 2 sin A cos B. Same way, which means S A plus B plus S A minus B is equal to 2 SA CB. I'm just calling it in shorter form. Let's subtract both equations. We would get S of A plus B minus S of A minus B, which would give you 2 cos A sin B. So here's how the formula dramatically changes. So in 9th equation, you got 2 sin A cos B, and in 10th equation, you got the opposite, 2 cos A sin B. Just because of addition and subtraction, you result in two different drastic differences. Same way, 3 and 4 would give you, which means cos of A plus B minus cos of A minus B equal to 2 cos A cos B. And 3 minus 4 would result you with cos of A plus B. Sorry, this is plus, right? Okay. Now, cos of A minus B would give you with sin A sin B. Wait. Sorry, minus 2 sin A sin B. Putting negative on both sides would give cos of A minus B in the front and cos of A plus B sin A sin B. These are all really important trigonometric identities. It would feel complex, but actually it isn't. If you just remember this first 4 equation, you can derive all other equations very simply. It's just a basic one, just adding and subtracting of combinations of the equations. So there is no trouble in this. Everything is fine. Now another equation like sine, what we saw, the combination of addition and subtraction with basic 4 identities which we saw right now. What if the 1 and 2 equation got multiplied, and what would be that result? That also let's see. S of A plus B dot S of A minus B would give you S square A minus a square b, or else c square b minus c square a. Some of you get like collapsed y s square a minus s square b, and in cos terms y it is c square b minus c square a. Here they use the identity sin square theta plus cos square theta equal to 1. So that while substituting s square a, they would be substituting it as 1 minus c square a, so that sign difference would arrive. Okay. Same way, 3 and 4, let's multiply. C of A plus B dot C of A minus B would give us C square A minus S square B, which is also equal to S square A, in the sense C square B minus S square A. Another important one, let's see that tan of A plus B. Okay, 5 and 6. Let's multiply. We would end up getting tan of A plus B dot tan of A minus B. What would be this identity? T square A minus T square B divided by 1 minus TA TB. TA square TB square. Sorry. So tan of A plus B into tan of A minus B would give you tan square A minus tan square B divided by 1 minus tan A square tan B square. Same way, cot of A plus B, cot of A minus B. I'm just putting it as cot in order to avoid confusion with cos, which is denoted as C. Okay. Cot square A, cot, cot square B minus 1 divided by cot square B minus cot square A. Okay. Now there is a very important identity. This is mostly useful in some of the numericals when we solve. This is a very important identity. Tan of 45 degree plus theta is equal to, uh, we popularly know that tan of A plus B is equal to tan A plus tan B divided by 1 minus tan A tan B, as per the fifth equation we just solved, right? In that, let's substitute A as 45 degree and B as theta. We would get 1 plus tan theta divided by 1 minus tan theta. Now, let's substitute tan theta as S theta divided by C theta. Okay, same way. 1 minus S theta C theta. We would get C theta plus S theta divided by C theta. And same way, C theta minus S theta divided by C theta. So C theta cancel. We would get C theta plus S theta divided by C theta minus S theta. 1 plus t theta divided by 1 minus t theta, which is also equal to tan of 45 plus theta. This is also equal to cot of 45 minus theta. Very, very important one. Same way, tan of 45 minus theta is equal to just a negation 1 minus t theta divided by 1 plus t theta, which is also equal to c theta minus s theta divided by c theta plus s theta, which is also equal to cot of 45 plus theta. So there is also a popular thing. You can easily visualize from this equation, from this two equation 17 and equation 18. The numerator becomes the denominator in the 18th numerator of 17th equation will be the denominator of 18th equation, and the denominator of 17th equation will be the numerator of 18th equation. So it's basically a reversal of numerator and denominator. It's just a reciprocal. So what if we multiply both of them, 17 into 18 would give you tan of 45 degree plus theta dot tan of 45 minus theta equal to 1. So these are the derived identities from just 4 equations: sin of a plus b, sin of a minus b, cos of a plus b, cos of a minus b. So you can deduce 19 different equations from like 15 different equations from just 4 identities, and this is compound angles where you could able to get some gigantic expressions like this, and there isn't any difficulty in like memorizing or something. You just need to know these 4 basic equations, and you can easily derive whatever we want as per that particular situation, and what that particular problem demands, and you can substitute the required things based on that. Let's see few more identities and few more equation in next episode. Thank you.